The ancient Greeks invented electricity. Wait a second, I thought that electricity was invented in the 18th century by some Italian or Greek dude, but it turns out it's actually much older than that. In fact, it's so old that the ancient Greeks were using it back before the Egyptian pyramids were built. But how did they do this? And why is this important? Let's find out in today's episode. Hi, I'm here to introduce you to my channel. Every week we bring you new episodes about the amazing world of physics. Before we start, I want to thank all the supporters who helped us make this video. If you enjoy learning physics and tech stories, consider supporting us too. We really appreciate it. Have you ever wondered what happens when you rub a balloon against your hair and then put it near some small pieces of paper? The balloon will attract the pieces of paper even though they're not touching. You can pick them up like this. This effect is caused by something called static electricity, which you probably learned about in school. It happens because when you rub the balloon against your hair, electrons, which are negatively charged particles that lurk within atoms, get transferred from your hair to the balloon. Since the balloon now has more electrons than before, it becomes negatively charged overall. Electrons normally want to be close to each other, since they have the same charge and repel each other. So if you bring the negatively charged balloon close to some small piece of paper, the electrons inside the paper will move away from the balloon, making the molecules in the paper positively charged. The attraction between opposite charges causes the paper to be pulled toward the balloon. But while this example is fairly modern, the ancient Greeks were already experimenting with static electricity thousands of years ago. The Greek Thales of Miletus is credited with rubbing amber with a piece of linen cloth and thereby creating electric sparks. Amber is a material made of fossilized tree resin that has been hardened by pressure over time. When Thales rubbed the amber, electrons jumped from the linen onto the amber, charging it. He was so surprised to see this strange phenomenon that he named it electron, which is where we get our word electricity. However, Thales didn't invent electricity. He just happened to notice this effect by chance. In reality, the ancient Greeks were already using devices that generated electricity hundreds of years before Thales. These were simple devices that used static electricity to generate small electric shocks. They were called electric fish. They consisted of two pieces of amber attached to a wooden stick with a string. One piece of amber would be rubbed vigorously with the hand, while the other one was held stationary. Then the charged amber would give an electric shock to anyone who touched it. Electric fish weren't just fun to play with. They were also used for medical treatments. It was believed that the electric shocks could cure various ailments, such as toothaches. Unfortunately, it doesn't seem to have worked all that well, since we still need dentists today. It was until 600 years later that the Greek philosopher and polymath Aristotle took a closer look at these electric fish. Unlike Thales, he understood that rubbing the amber wasn't generating the electricity, but was transferring it from one object to another. This is essentially correct. However, he didn't know about electrons, so he thought that it was actually the air that was being charged instead of the amber. According to his theory, rubbing the amber heated the air inside it, and this hot air was then released upon rubbing and gave a shock when touched. While incorrect, his reasoning was far more advanced than anything else at the time. Besides electric fish, the Greeks were also fascinated by another natural phenomenon that displayed static electricity, namely the electric eel. This fish, which lives in the waters around Greece, has the remarkable ability to generate electric shocks by itself. Just like the electric fish, these electric eels were also used to treat medical conditions, such as in cases of impotence. Even though there's no evidence that this treatment was any more effective than rubbing amber, which I think is putting it mildly. The Greeks also believed that the electric eels could detect precious metals such as gold. Supposedly, an electric eel placed in water would immediately swim to the spot where a gold coin had been thrown in. How useful. During those times, the Greeks were not the only ones experimenting with electricity. Over in Egypt, the priests knew that hooking two pieces of amber together and rubbing one of them produced an electric spark. They used this effect to power simple machines, such as a wheel that would spin when activated by a spark jumping across a gap. In addition, the Egyptians, along with other cultures such as the Chinese, were familiar with the lodestone, naturally magnetic rocks that occur when iron is oxidized. In Greece, it was the philosopher and mathematician Pythagoras who first described how a compass needle aligns itself with the north and south poles of a magnet. He also discovered that a moving magnet could induce electric currents in a nearby metal. For example, if you drop a magnet down a copper pipe, the magnet won't fall all the way down, but hover above the pipe as the induced current creates a magnetic field that repels the magnet. This discovery was extremely important for the development of electromagnetism later on. Although the Greeks had no idea that the Earth is a giant magnet, they loved magnets nonetheless. The Greeks even had a word for it, meaning stone that guides itself. In their eyes, the lodestones were almost magical because they could attract iron objects such as weapons. That's why the Greeks used lodestones to make simple catapults and other war machines. Now back in Greece, the philosopher Anaxagoras suggested that electricity and magnetism were linked in some way. To him, magnetism seemed to be a form of electricity that was anchored to a particular spot. This was a pretty good guess, but it turned out that the relationship between electricity and magnetism was even more profound than Anaxagoras had imagined. The ancient Greeks lived during a period sometimes referred to as the Classical Age, a time when philosophy, arts, and science flourished in Greece. It lasted from roughly the 8th century BC until the end of the 6th century BC. During this period, many scientists conducted experiments that laid the groundwork for future discoveries in mathematics, astronomy, and physics. For instance, the Greek Thales also predicted solar eclipses, discovered the center of gravity, and proposed a geometric proof that the Earth is round. His student, the philosopher and mathematician Pythagoras, was responsible for important theorems in geometry, including the famous Pythagorean theorem, a squared plus b squared equals c squared. And it was Pythagoras who first explored the properties of right triangles. Other Greek scientists, such as Anaximander, created the first map of the world showing known parts of Europe, Asia, and Africa. Back then, the Greeks had no idea that their experiments dealt with electricity. However, they left behind records of their work, which allowed later generations to build upon their discoveries. The scientific knowledge of the ancient Greeks spread throughout the Mediterranean, influencing civilizations like the Roman Empire. However, after the decline of the Classical Age, scientific development slowed down considerably. It wasn't until the Middle Ages that interest in science revived in the Islamic world. Muslim scholars translated Greek texts into Arabic and made significant contributions to various fields. During the Renaissance, the scientific knowledge of the Greeks and the Muslims was rediscovered in Europe and sparked a new wave of scientific inquiry, leading to groundbreaking discoveries and inventions. Today, we take electricity for granted. It powers our homes, drives our industries, and connects us through communication networks. Yet it wasn't until the 18th century that we began to understand its true nature. The invention of devices such as the Leyden jar, a primitive capacitor used to store electrical charge, and the electric motor, which converts electrical energy into mechanical energy, marked a significant leap forward. Scientists like Benjamin Franklin, Alessandro Volta, and Michael Faraday made crucial discoveries about electricity and magnetism, laying the foundation for modern electrical systems. So while the ancient Greeks had observed and experimented with static electricity, it wasn't until much later that electricity became a well-understood phenomenon and a practical tool. Nonetheless, their early investigations and the knowledge they passed down through the ages played a role in shaping our understanding of the natural world and inspired future generations of scientists to explore the mysteries of electricity and magnetism. The ancient Greeks didn't have the tools or knowledge to really explore physics, but they were keen observers of the natural world, and they were curious about how things worked. Their experiments with electricity were a testament to their thirst for knowledge and their desire to understand the world around them. Even though their understanding of electricity was limited, their observations and experiments paved the way for future discoveries and laid the foundation for the scientific progress that would come later. If you like this video, check out our other episodes. And if you really love what we're doing, support us. We have several tiers of membership with exclusive perks such as blooper reels, behind-the-scenes content, and even your name in the credits. Visit our support page to learn more. Thanks for watching.